Hello students, I am Sanjay Shirude, teacher in mathematics from Willingdon College, Sangli. Last time we learned differentiation and logarithmic differentiation. Today we will continue the same logarithmic differentiation with the help of PowerPoint presentation. Now we will continue the same topic, that is logarithmic differentiation. Here we consider this example, y equal to sin x raised to x. Now remember this example, and also we will see the next example and we compare both the examples. See here, y equal to sin x to the power x. Now by taking log of both sides, why we take log? Because this is the function raised to function. So we consider log of both sides and we get this. Now what is our next step? Now this x becomes multiple now. Power becomes multiple. Log a raised to m, m log a. So we write x into log of sin x. Now differentiate both the sides with respect to x. We get d by dx of log y equal to d by dx of right hand side, that is x into log of sin x. Now we consider the product d by dx of u into v, that is u into dv by dx plus v into du by dx. Now say this function x, that is u. Second function log of sin x, say that is v. And by using this rule, that is the product rule, we write our next step as, see here, derivative of log y on left hand side becomes 1 upon y into dy by dx. On the right hand side we use product rule. So x into first function into derivative of second function, that is d by dx of log of sin x, plus second function, that is log of sin x, into derivative of first, that is d by dx of 1. And you know very well this is 1. Derivative of x is 1. Now derivative of log of sin x is 1 upon sin x into derivative of sin x. So our next step is this. X as it is, derivative of log of sin x is 1 upon sin x and into derivative of sin x by using chain rule. Now plus log of sin x remains the same. Derivative of x is 1 now. See here, by taking y on right hand side, denominator becomes numerator. So y is equal to sin x raised to x. So we put the value of y here. And now this bracket becomes, see here, derivative of sin x is cos x. X into 1 upon sin x as it is, plus log of a sin x into 1, that is log of sin x. And now this is our answer. Sin x raised to x, x into cos upon sin, that is cot. So we write cot x and log of sin x as it is. And now this is our answer. Here we use sin square theta equal to sin theta bracket square. So we write sin x raised to x, that is sin x the power of sin to the power x of x by using this. Now we will continue the next example. See here, this is y equal to sin of x raised to x. And in previous example, what we see? Sin of x raised to x. Now, what is the difference between these two? Y equal to sin of x whole raised to x and y equal to sin of x raised to x. In previous example, we are given y equal to sin to the power x of x, that is sin x raised to x. Now this is the difference between these two examples. Now we are going to solve this example. Here our next step is y is equal to sin of x raised to x. I write this x to the power x in bracket now. And now by taking log of both sides, see here, here we consider x to the power x equal to u first. So we write y equal to sin u, where u equal to x to the power x. Now we taking derivative of both sides. What happened? dy by du equal to d by du of sin u. Now derivative of sin u is cos u. And here we resubstitute the value of u, that is x to the power x, and we say this is number 1. Now we consider this u equal to x raised to x. And here by taking log of both sides now, because this function is of the type function raised to function. So we take log of both sides, we get log u equal to log of x to the power x. Now here log u equal to x into derivative of log u is 1 upon u and into du by dx, because we consider differentiation with respect to x. Now again by using product rule, x into derivative of log x plus log x into derivative of x. So what is our next step? Du by dx equal to x to the power x into 1 plus log x. We take this u on the right hand side and value of u is x raised to x. So we write this, and here derivative of log x is 1 upon x, x into 1 upon x becomes 1, and here derivative of x is 1. So 1 into log x, that is log x. Finally you say that derivative of x raised to x is this. And now from 1 and 2, see here what we say. First we consider by chain rule dy by dx equal to dy by du into du by dx, and now from 1 and 2 we substitute the values here. What we get? Dy by dx equal to dy by du, that is cos of x raised to x. So we write this. Du by dx means this, x to the power x into 1 plus log x. So we write this, and now this is our answer. We write here the reason from 1 and 2. So derivative of sine of x raised to x is cos of x raised to x into x to the power x in bracket 1 plus log x. Now this is our final answer. And now we will continue the next example, next type. See here, differentiate the following with respect to x. It is from exercise number 1.3 and example number 2. Our first example is y equal to x to the power e plus x to the power x plus e to the power x plus e to the power e. Now we differentiate both the sides with respect to x. So dy by dx equal to d by dx of right hand side, that is this. By using addition rule, we have to take derivative of every term, each term, and now we write here derivative of first term plus derivative of second term plus derivative of third term and so on. Now first number, third number and fourth number, these functions are very simple. We can write their derivatives directly, but here second function is of the type x to the power x. And we already calculate the derivative of x to the power x in previous example. See here, we use here this formula, derivative of x raised to n equal to n into x raised to n minus 1. So we write here derivative of x to the power e is e into x to the power e minus 1 by using this formula. We write second term as it is. We can calculate this derivative separately now. In previous example also we can find it. Now here derivative of e raised to x is e raised to x, and here e to the power e is a constant, so its derivative must be 0. So here I write plus 0, and we denote it by equation 1. And now again we consider this function as u equal to x raised to x. Now by taking log of both sides we get log u equal to log of x to the power x. So log u equal to x into log x. And by taking derivative of both sides, derivative of log u is 1 upon u into du by dx is equal to derivative of right hand side, this is u into v type. So by using product rule, say this is u, this is v, we write this first function into derivative of second, that is x into derivative of log x plus log x into derivative of x. So du by dx equal to, finally we write x to the power x into 1 plus log x. Already we solved such an example in previous example. So I write directly now this du by dx equal to x to the power x into 1 plus log x. Now you are also remember such examples. Memorize this answer now. For the derivative of x to the power x is directly you write x to the power x into 1 plus log x. Say this is number 2. Now we put this value here and we get, see here what we get, dy by dx equal to first term as it is, derivative of x raised to x is this, so I write this, and last term e raised to x as it is. Now this becomes our answer. Derivative of this given function is this, and now this is our final answer. And now to see our next example. See here, y is equal to x to the power x to the power x, function raised to function raised to function, and here again plus e to the power x raised to x. First, we denote first function by u and second function by v. So here I write y equal to u plus v. Say, what is u? Where u equal to x to the power x to the power x and v equal to e to the power x raised to x. And now if you differentiate this, you will write this dy by dx equal to du by dx plus dv by dx. We denote it by equation 1. Now we consider u equal to x to the power x to the power x, function raised to function raised to function. So we take naturally log of both sides, log u equal to log of right hand side. Now this x as the base I write in bracket. And now our next step is this, x to the power x into log x. Now by taking derivative of both sides, what we get? D by dx of log u equal to d by dx of x to the power x into log x. Again we use here product rule, d by dx of u into v. And now our next step is, see here, derivative of log u is 1 upon u into du by dx is equal to first function x raised to x into derivative of second function, that is d by dx of log x, plus second function log x into derivative of first function, that is d by dx of x raised to x. Now we write here directly y equal to x raised to x log y equal to log of x raised to x, and we write directly dy by dx equal to x to the power x into 1 plus log x. What is y? X to the power x. So you write this derivative is equal to this directly. Now we solve this example here in previous example also, and now our next step is 1 upon u into du by dx, x to the power x as it is, derivative of log x is 1 upon x plus log x, and here I write the derivative of x raised to x is this. So we write here into x raised to x into 1 plus log x. Now this is our previous step. By taking this 1 upon u on right hand side, it becomes u into right hand side. Now see here, x to the power x upon x we write as the first term, log x into x raised to x we write as it is into 1 plus log x as it is, and now we substitute the value of u here, that is x to the power x to the power x, and now we have to take a common from this x to the power x into log x. By taking common x to the power x into log x, in bracket we get 1 plus log x plus 1 upon x into log x. When you take x to the power x into log x as a common, that means you have to divide here x to the power x into log x. After simplifying, you will get this. Now students, we say this is number 2. And now we consider our next function, that is v. And now here we take again log of both sides. We get log v equal to log of e to the power x raised to x. Now this power becomes multiple here by using rules of logarithm. So we write x to the power x into log e. And you know very well the value of a log e is nothing but 1. So our next step is x to the power x into 1, that is x to the power x. And now it becomes x to the power x, and we take derivative of both sides, we get this now. D by dx of log v is equal to d by dx of x to the power x. Here you write log e equal to 1. See here, I will write this step here, x to the power x into 1, and that is x to the power x. And then we take the derivative of both sides and we write this step. And now derivative of log v, that is 1 upon v into dv by dx. Now derivative of this function x raised to x, I write now directly here x to the power x into 1 plus log x. Now take this v on this side. What do we get? dv by dx equal to, what is the value of v? That is e to the power x raised to x Now x raised to x as it is, this bracket as it is, we say this is number 3. From 2 and 3, we put the values of dv by dx as well as du by dx in equation 1. So we write here, from equations 2 and 3, equation 1 becomes, see here, dy by dx equal to this, du by dx plus dv by dx. So here this is the value of du by dx plus dv by dx, and now this becomes our final answer. See here, we write in simple form x to the power x into x to the power x raised to x into log x into bracket 1 plus log x plus 1 upon x into log x plus x to the power x into e to the power x raised to x into 1 plus log x. You may take common here again and you can simplify it, but it is not necessary to us. Now we will continue our next example. Y is equal to e to the power tan x plus log x to the power tan x. Again, we consider first function as u. We denote the second function by v. And so we write y equal to u plus v. We write in brackets say. And now where u equal to e to the power tan x and v equal to log x to the power tan x, we write the values of u and v. We mention them. And now we take the derivative of both the sides. We write this dy by dx equal to du by dx plus dv by dx, and we denote it by equation 1. That means now to find first du by dx by using this and dv by dx by using this, and then substitute the values of du by dx and dv by dx in equation 1. So we consider first function u equal to e to the power tan x by taking log u equal to log of e to the power tan x. That means tan x into log e. Again, you know very well log e equal to 1. So we write log u equal to tan x because log e equal to 1. So we write directly. Now by taking derivative of both sides with respect to x, d by dx of log u equal to d by dx of tan x. And it is very simple now. Derivative of log u is 1 upon u into du by dx, and derivative of tan x is sec square x. Now take this u from denominator on right hand side, it becomes numerator. So what do we get? Du by dx equal to u into sec square x. But what is u? That is e to the power tan x. So I write directly e to the power tan x into sec square x. We say number 2. Similarly, we consider the second function v equal to log x to the power tan x here. And now by taking log of both sides, log v equal to log of log x to the power tan x. After simplifying, we write on right hand side tan x into log of log x. This power becomes multiple by using rules of logarithm. Here, by taking derivative of both sides, we get this d by dx of log v equal to d by dx of right hand side, that is tan x into log of log x. So what we get? Here we use again product rule. Say this is first function u into second function v, d by dx of u into v. That can be written as first function u, that is tan x, into derivative of second function, that is log of log x, plus second function log of log x into derivative of first function, that is tan x. We use here product rule. And now derivative of log v, that is 1 upon v into dv by dx, derivative of tan of log x. Now tan x as it is, derivative of log x can be written as 1 upon log x into 1 by x. Derivative of log x is 1 upon log x into 1 upon x by chain rule. And here log of log x remains the same, and derivative of tan x is sec square x. Now this is our step. And now take this v from denominator from left hand side to the right hand side in numerator. So we write v into right hand side. It becomes tan x upon x log x plus log of log x into sec square x. And now here we put the value of v as log x raised to tan x, and we denote it by equation 3. And now we say that from 2 and 3, equation 1 becomes dy by dx equal to du by dx plus dv by dx, and we write this. This is du by dx and this is dv by dx. And it shows our final required answer. And now, to go on next slide, to continue our next example, y equal to tan x raised to tan x raised to tan x at x equal to pi by 4. Students, see here, what is our right hand side here? Function raised to function raised to function. Naturally, we take log of both sides and then we simplify it and then we take derivative of both sides. See here, log y equal to log of tan x raised to tan x raised to tan x. So what we get? This power becomes multiple here. Again, in next step, this is again power. It becomes multiple. So tan x into tan x becomes tan square x. So we write this log y equal to tan square into log of tan x. By taking derivative of both sides with respect to x, we get d by dx into log y is equal to d by dx into tan square x into log tan x. Say this is u and this is v. Again, by using product rule, you know very well d by dx of uv. That is, I write here for you derivative of u into v, u into dv by dx plus v into du by first function, second function. First function into derivative of second and second function into derivative of first. And now we have to solve this derivative of log y, that is 1 upon y into, and now we will see our next step. See here, tan square x as it is as the first function into derivative of second, that is derivative of log of tan x. Here I write that. Now second function into derivative of first, that is d by dx of tan square x. Now what is our next step? Here I write the derivative of log y, that is 1 upon y into dy by dx. Here tan square x as it is, derivative of log of tan x, that is 1 upon tan x into derivative of tan x by using chain rule. Now plus log of tan x remains the same into derivative of tan square x. So it becomes 2 tan x into derivative of tan x. Now in next step we have to write derivative of tan x here and here also as sec square x. So I write here derivative of tan x is sec square x. Here also I write derivative of tan x is same thing, that is sec square x, and I take this y on this side, right hand side. It becomes numerator. So y into right hand side. And so we have to simplify this. We substitute the value of y. This is the value of y. Tan x raised to tan x raised to tan x. I write here. Now here, see, tan x into sec square x is common, can be taken out. In bracket, what we write? See here, first tan x get cancelled, now tan into sec square get common. So we write 1 as the first term, and here tan x into sec square as a common, then you write 2 into log of tan x. So our next step is to find, this is our final derivative. But we have to find the value of this derivative at x equal to pi by 4. So here we have to substitute in this answer x equal to pi by 4. Then what we get? dy by dx at x equal to pi by 4 equal to this right hand side, that means derivative at x equal to pi by 4. That means we put x equal to pi by 4 here, here also and here also. In next term we write x equal to pi by 4 in each term. And now you know very well tan pi by 4 is 1. So 1 raised to 1 raised to 1 and it becomes 1. So our next step is, see, 1 to the power 1 to the power 1. Now here tan pi by 4, that is 1. Sec pi by 4, that is root 2. But the sec square pi by 4, that is root 2 square, that is 2. Now 1 as it is plus 2 times log of tan pi by 4, tan pi by 4 means 1. So 2 into log 1. Now our next step becomes, see here, now this becomes 1, this becomes 2. So I write here 2 into 1 as it is. Now 2 into what is log 1? You know very well. The value of log 1 is 0. So 2 into 0 becomes 2 into 0, that is 0. And so finally you write 2 into 1 plus 0, so 2 into 1, and that is 2. Now this becomes our answer. Students, now we will continue our next unit, explicit and implicit function. Now this is also very, very important. First we are going to see what is meant by explicit function, then we are going to see what is meant by implicit function. Now we consider any function of the type y is equal to f of x here, in which y is exclusively, that means directly expressed in terms of x. That means y is any function of x. It is a clear function in x. Then you say that it is explicit function. Like y equal to x square plus 2x plus 3, y equal to e raised to x minus log x, and so on. So our right hand side is in terms of only x. Then you say that it is an implicit function. Students, here I write y equal to f of x, or you may say that x equal to g of y, are said to be explicit function. Here y is clearly, you say that it is a function of x. Here x is a function of y. So both are explicit functions. In such a functions, given the value of x here, we can find the corresponding value of y. In explicit function, if we are given the value of x, then you can find the value of y. Now, for example, here we consider first example, y equal to x square plus 5x minus 7. See here, on right hand side, only one variable is there, that is x. Same thing is here. And both are the explicit functions. On the other hand, a relation in which neither x nor y can be expressed exclusively, means directly in terms of the other variable, is called an implicit function. Means, remember this thing, here y is clearly defined in one variable, but on the other hand, a relation in which neither x nor y can be expressed exclusively directly in terms of the other, then you say that it is an implicit function. The most general form of the implicit function is given by f of xy equal to 0. That is function in both the variables x as well as y. That means x square y plus y square x equal to 0, and so on. So we say that in implicit functions, more than one term in y is present in different forms along with the terms of x. Means, in such a functions, given the value of x, we cannot find the corresponding value of y. In explicit function, we can find the value of y when the value of x is given. So, in implicit function, that is impossible. Now, for example, see here student, x square plus 5xy plus y square. Now, this is a function f of xy equal to 0. We denote it by f of xy because both the variables are present here. Similarly, we can define this function as f of xy equal to 0. Now, there are both the variables. We can't separate both the variables. So, we say that they are implicit functions. And now, derivatives of implicit functions, we are going to see. Differentiate both sides of the equation with respect to x. If we are given such a type of function, then we remember this thing. We have to differentiate both the sides of such an equation with respect to x, that is independent variable, treating y as a differentiable function of x. मुलांनो या ठिकाणी तुम्ही समजाल की दोन व्हेरिएबल्स दिले, मग डिफरन्शिएट विथ रिस्पेक्ट टू एक्स म्हटलं की वाय हा सुद्धा एक्स फंक्शन आहे असं गृहीत धरायचं आहे. And so we write this. And now again remember this thing, collect the terms containing dy by dx on one side of the equation and solve for dy by dx. That means we have to take all the terms dy by dx of both the sides on left hand side and then simplify it. Students, we will stop here and we will continue in the next lecture. Thank you. Thank you very much.